Okay, who can tell me some things that were a little bit like confusing last night? When you were working, what are some things that you had to like stop and you're like, I don't know. Waylon?
On the back side, when you don't know like 35 times 38 and you have to change both of them.
Okay, so he said like sometimes when you try and change one of them and it's not a mental math problem, so then you have to change both of them. Yep. Trying to decide if you can just change one or if you have to change both of them sometimes is confusing. Why will that be different for each person? Potentially. Emma?
Because everyone else knows what they can do.
Yeah, because your mental math capabilities and the mental math capabilities of the person next to you, are they exactly the same? No, so right now everybody's worksheet should be out on your desk. It should be open. I want you to have out a pen. Put all pencils away. Get out a pen. Put all pencils away. Okay, on these, there are lots of answers that could be correct. So for each one of them, we're going to talk about all of the possible estimations that would be correct. We're also going to talk about some that possibly aren't correct. Okay, Rory, what did you have for number 1?
Change the 69 to 70.
Okay,
5 times 70 equals 350.
good job. 5 times 70 equals 350. Why is that probably the only estimation we should have on that one? Waylon?
Because 5 is a single digit number.
Yep, 5 is a single digit number, and we said if it's a single digit number, try and leave it alone. Why do we want to try and leave it alone? Caleb?
Because you probably know your single digit numbers.
Okay, we probably know our single digit number multiplication facts, because when we round the other one, it's really single digit times single digit. Mila?
There's really nothing to change.
Yeah, if we changed it, we would either change it up to 10, which is quite a bit of ways from it, or down to 0. Why do we never want to round something down to 0, Brennan?
Because it's 0 no matter what.
Yeah, because if you multiply something by 0, you will always get 0. So we never want to go down to 0. So again, single digits, try and just leave them alone. Waylon, number 2, what did you have? This is one where we might have 3 to 4 different answers that are all okay. Waylon, what'd you put?
I changed the 11 to 10 and the 119 to 120.
Okay, so he changed them both. I agree, that is an okay answer. Just change one. Who can just change one? Madison?
11 times, I put 100.
Okay, 11 times 100 would be what?
1,100.
1,100. And since you gave me that, I'm going to say this one's okay. Let's leave the 11. What could we change 119 to still have a mental math problem but be way closer to the actual answer? 120. Why do you think, since you gave me this one, why do you think this is a better one?
Because 120 is higher.
120 is higher than 119, but how much higher?
It's going to give you the better estimate.
It's only one higher. How much lower is 100? 19. So we had to change it 19 to get to 100, but if we went up by 1, we got it to an easy number also. Does that make sense? So if you have this one, that is an okay estimate, okay? In the world of estimates, that one is okay. This one is better. Who can give me another one where we're just changing 1? Mila?
11 times 110.
Okay, now if you're going to round this, I would prefer you round it there. Why do you think I'd prefer you to go to 120 rather than 110?
Because it's easier if you have a higher number.
No, it's not easier if you have a higher number. If you round 119 properly to the nearest 10, where does it take us? Who can answer that? 119 to the nearest 10. Kylie?
120.
120. It's because that's rounded properly. Now, if we look at that and we're like, hey, I don't know. Ooh, hold on. Hold on. Let me back up. Let me back way up. Did anybody catch my error?
Yeah.
Sorry, no one said anything. I just realized what we wrote there. I'm getting ahead of myself. Mental math problem. Why might this not be the best estimate for some people? Emma Lapp?
Because they might not know their 12s.
Okay, so is that why you changed it? Okay, good. Sorry, I had it wrong up here. So 11 times 12, if you look at that and you're like, I do not know 11 times 12, I should, but I forgot it. Rory, what is 11 times 12?
132.
132, and then I add my 0. Okay, so Mila said, hey, I rounded it to 11 times 120, and I don't know what 11 times 120 is, but I do know what 11 times 11 is. Is that what you did?
Yeah.
Okay, what's 11 times 11?
121.
121, add a 0. Okay, now I understand your thought process. Is that okay? Is that still a closer estimate than that one? Yes. Okay, anybody have another one? I'm going to have another one. What if we left 119 as 119? We left one of them alone. Michaela, what could I change the 11 to? To make a 10. That's about the only mental math problem I could change that to. That's the only multiple of 119 that we know. So on that one, we have several that are all okay. Who can tell me when and why would we ever need to estimate? Besides in a word problem that says estimate or about. Aubrey?
Whenever it is where you have a very hard problem and you don't really know what to do, you can round or estimate.
Okay, I'm gonna go with your first part. When you have a really hard math problem, let's say a 3x3 algorithm multiplication problem, what makes those tricky? Mila?
If they're like they have numbers and they don't have a 0 on it.
Okay, if there's no zeros in it, we have lots of math facts, right? Raise your hand if you sometimes make goofy mistakes when you're doing 3x3 multiplication. Okay, we might forget zeros, we might do math facts wrong. So estimation is supposed to be quick and easy. So you work your long 3-digit problem, get an answer, do a quick estimate of it. If your estimate says I should be close to 1,200 and you get 20,000, are you close? No. So now that tells you, hey, I did something wrong. First, recheck your estimate. That's the easiest one to double check. And if you're like, no, my estimate's good, so I should be getting close to 1,200, rework your problem. Check your zeros. Make sure you have zeros where you need zeros. If you have zeros where you need zeros, then go back and do your math again. Okay, so it's really to help you help yourself. Check them. Quick and easy. Number 3, Brennan, what did you change number 3 to?
I did 8 times 300.
8 times 300 is perfect. Why do we not want to change that 8, Brennan?
Because 8 is a single digit number.
Yep, so we want to leave it be. Why would we not want to take 289 down, Emma? E? Yeah, I don't think anybody in here knows their multiples of 29. If we rounded that to the nearest, if we went down, we would go down to 200. We do know 8 times 2, but is that the proper way to round 289? No. Could potentially some people go to 250. If you really like quarters, you might know if you have 8 quarters, how many cents do you have? So how many cents is that? 200 cents. Yep. So again, if you can think money, is this an okay estimate? Yeah, this is probably the best one for you guys right now, though. Number 4, Grayson.
50 times 20.
I agree with your 20. Where would we round 55 to?
60.
60, okay? And it would, on the world of estimating, the answer would be between the estimate of 50 times 20 and 60 times 20, our actual. 6 times 2 is 12, and we add our zeros. Good job. Anybody have something else for that one? Ty?
55 times 20.
Okay, can you do 55 times 2 mentally?
Yeah, it's 110.
Okay, so my class said that one too. 55 times 20, and this is where if you look at that and you're like, I don't know 55 times 2 real quick in my head, is that the estimate for you? No, but if you say 55 times 2 is 110 and you add your 0, then that estimate is okay. Mila?
50 times 10.
Okay, we don't want to take this one down to 50. Why?
Because then we also have zeros.
No, that would be okay. If we round 55 to the nearest 10, since this is a 5, what would it do to that 5? Bump it up. Number 5, Dylan, what'd you come up with?
30 times 40.
30 times 40 is probably the best estimate. 3 times 4 is 12. Add our zeros. Number 6, Callie?
9 times 20.
9 times 20, 180. Scroll on down. Number 7, Caleb? 200 times 9 is probably the best estimate. Kylie, next one.
I did 660 times 60.
Okay, 660 times 60. If we rounded this to the nearest 10, do you know what 66 times 10 is on the top of your head? So fix it. What should you have? Can you change this to be able to do it mentally?
You could change it to 700.
Yes. Yep. There we go. 700 times 60. 7 times 6 is 42, and we add our 3 zeros. Noelle, next one.
80 times 90.
80 times 90 is great. So 8 times 9 is 72, and I add my zeros. Waylon, last one.
50 times 20.
Okay, 50 times 20. 5 times 2 is 10. We add our 2 zeros. Did anybody do that? Rory, what's 15 times 5 without looking at your paper?
750.
15 times 5.
Oh, wait, 15?
75. Okay, so if you know your multiples of 15, because some of us, we know our 12s, we don't know our 13s, we don't know our 14s, but we know our 15s. If you know 15 times 5 is 750, does that way work? Colby, stop, please. Yes. If not, 50 times 20 is 100% okay. Flip your paper to the back. Now that we've gone over several on the front, I want you to look at yours on the back and see if there's any of them that, now that we've gone over some, Brennan, you disagree with. If you disagree with what you thought it was last night, I want you to change it right now with pen while I get it pulled up. Okay, number 1, Drake, what is my actual multiplication problem I should have came up with?
78 times 23.
78 times 23. Callie, what can I round that to make it easier to work out?
80 times 20.
80 times 20, good job. Number 2, Aubrey, actual.
37 times 50.
Why do we like that one in an estimation problem?
Because there's already one that is already in the 10.
Yeah, one of them's already rounded to a 10 or already a 10. It's not rounded. Noelle, what is your estimation problem?
40 times 50.
Good job. 40 times 50. You didn't have to solve these ones. Number 3, Caleb, go for it.
23 times 12.
23 times 12. Estimated problem, Easton T. Arabelle, put your book away, please.
12 times 20.
12 times 20. I'm going to write it as 20 times 12 just because I had it that way there. Could you have done 20 times 10 on that one?
Yes.
Yes. Which one would give us the closest estimate?
20 times 12.
20 times 12. Okay. Number 4. Waylon, go ahead.
67 times 40.
Okay. Cam, give me the estimated problem. Or rounded problem.
70 times 40.
Good job. 70 times 40. Number 5, Brennan.
12 times 79.
12 times 79. Rounded. Audrey?
10 times 80.
10 times 80 is okay. What else could we have done?
12 times 80.
If you know your multiples of 12 up to 8, could you have done 12 times 80? Yeah, if you don't know that 12 times 8 is 96, is that the way to go for you?
No.
Nope, this one is okay. Okay, if you don't know your multiples of 12 that high. Madison, number 6.
60 times 4.
So original first.
56 times
56 times 4, and she already told us that she changed that to 60 times 4. Why do we not want to touch the 4?
Because it's a single digit number.
Good job, it's a single digit number. Number 7, Kylie.
20 times 33.
20 times 33. Estimated Easton G. Number 7.
Times 30.
20 times 30. Good job. Number 8. Sophia.
35 times 38.
Okay, what did you change it to?
40 times 40.
Good job. 40 times 40. Mila, number 9.
71 times 52.
Good job. 71 times 52. Drake, what did you round that to?
70 times 50.
70 times 50. And the last one, Emma Lapp.
21 times 48.
21 times 48. And what did you round it to?
20 times 50.
20 times 50. Good job. Estimating. Thumbs up, thumbs down, or eh? Okay. And again, sometimes it's confusing because there are different ways that you can estimate. How do you decide which one is best for you? Okay, yeah, knowing what you are capable of mentally. If you have to do algorithm out to the side, what should that be telling you? You're doing it wrong. You're making it too difficult. Estimation and rounding the estimation is mental math. You change the problem, you round it to a mental math problem. If you are not doing mental math, you are doing it wrong. You're making your life too hard. Okay, keep those word problems out because today we're actually talking about word problems. Give me just a second to pass out these 2 pieces of paper. So today we are still doing all multiplication, okay? But on today's homework, I don't just ask you for the problem, I ask you why it's a multiplication problem. Because right now, yes, we are doing all multiplication. So you already know it's all going to be multiplication problems tonight. But I want you to start looking at problems and deciding why is it multiplication. Because pretty soon we're going to have addition, subtraction, and division all mixed together with multiplication. So you won't be able to just pull the 2 numbers out and put a multiplication sign between it and solve it. You will have to know why you are doing that. Okay, so that's what we're going to focus on today. On the 2 pieces of paper I gave you, one of them has 12 word problems on it. One of them is where we're going to do all of our work. I want you to flip to the back side of the one with the word problems. What is on the back side of that piece of paper, Brennan? Nothing. What do you think we're going to write on the back side of that paper?
Everything.
We're going to write some notes. Now, most of the time, in the lower grades, when you look for word problems, you look for keywords. Okay? That is a good thing to do. But there are lots of keywords that, depending on where they are given in the problem, can mean different things. Okay, like the word each. Each sometimes could be, it's a multiplication problem. Sometimes it could be a division problem. It depends if it's given in like the information section where it's giving us information, or if it is in the question. Okay, so when we're going over keywords, a lot of people give me words like that, like each, and they say that means multiply, and I say sometimes it does. But we can't just look at a word problem and see the word each and know that we multiply. We have to know where do we look for that word to tell us to multiply. So there is one scenario that comes up most often in 5th grade for multiplication problems. I'm going to write it and then I'm going to explain it. And you're going to write all of this on the back of your word problem. So your word problem is how it's kind of 2 worksheets in one. You should be on the back side. Okay, I want you to write. You can leave it sideways if you want. Right here, let's go ahead and write keywords just in the top. About halfway over, just draw a line and write scenario. Scenarios. Again, we're only going to talk about one scenario today because it is the most common in 5th grade word problems. So go ahead and throw out some keywords for me. Raise your hand and tell me some keywords that when I see them, my brain should say multiply. Waylon? No. Because it depends on where each is in the sentence. You're right, sometimes each. But I don't like to put that because sometimes it could also mean divide.
How many?
How many could be really anything, depending on how it's used in the sentence.
Estimate?
Estimate, we can estimate any operation. Mila?
Rounding?
Round is, that's what we do like with numbers or with our answer. We're thinking about words that when I see it, my brain says, ooh, I have to multiply. Caleb?
Area?
Okay, area, I will put, sometimes though when they give us area, it's a division problem. If they give us the area. So I'm going to put ask for. If they ask for area, yes, it's a multiplication problem. But if they say the area is 40, the length is 5, what is the width, that's a division problem. Grayson?
They say like yes, 8 times more.
Okay, so if they use the word times, I agree, that one always means multiply. Waylon?
Altogether?
Altogether could also be add. I know, there's a lot. That's why we're doing this, because in the lower grades, they focus all on keywords. But really, it depends on the context and where that keyword is used.
Multiplication?
If it says multiply, yes, we multiply. There's one more that always means multiply. Find the product. Product always means multiply. Okay, and you guys gave me a couple that, depending on how it's used in the sentence. So I'm going to talk about a scenario. Let's focus on the word each. Who can give me a sentence or a problem where the word each is used and it's a multiplication problem? Go ahead, Madison.
There were 5 boxes, and in each box there were 8 tricks.
What would your question be?
How many are there?
Okay. Waylon?
There is 7 dogs. I forgot what it is. Oh,
Kylie?
there are 5 groups in a classroom, and 5 kids sit at each table. How many kids are there?
Okay. Michaela?
There is 7 kids in each classroom in a hallway.
Do you have a question to go with that?
In the hallway.
Okay, we would need more information. So you guys are thinking the right idea. I'm going to give us a scenario, a problem that we're going to kind of dissect so that you understand what I'm going to write up here. So let's say there are, and I'm going to shorten it. I'm not writing out all the words. I'm skipping some words. There are 2 Skittles. Skittles in each bag. There are 2 Skittles in each bag. How many Skittles in, who thinks I could finish this question?
In each bag are there?
I already told you there's 2 in each bag. So what would the question maybe be asking, Cam?
In 5 bags.
In 5 bags. Okay, this is a scenario that you are going to start to recognize. And when you see it, you're going to be like, oop, that's a blah, blah, blah scenario. We call this, I want you to put a big star because this is what a lot of your answers are going to be tonight. We call this that's division. Give one, ask many. Which sounds like gibberish. Give one, ask many. This is a very, very common multiplication scenario. Okay? In this scenario, it gives one something. Underline the word something. What did it give me one of in that problem? What did it give me one of? Emma? I need a label. What did it give me one of? Caleb? So let's look. What did it give me one of? Did it give me one Skittle or one bag? Because those are the only 2 labels in my problem. Mila?
Bag.
It gave me one bag. It told me how many were in one bag. So it gives one something. In this case, it's bag. So go ahead and write bag next to it. Using words like, what word did they give me to tell me that it was one bag? Because it didn't say there are 2 Skittles in one bag. Dylan, what word could it use? Each. So it uses words like each. Are there any other words that I could replace the word each with and it still means one bag? Waylon? Altogether. So there are 2 Skittles altogether bag. So we're trying to replace that word each with a different word but means the same thing. Brennan?
I'm thinking.
Mila?
Together?
2 Skittles together bag. Emma? Every 2 Skittles in every bag. Does that still mean in one bag? Okay, so each, every, there's one more 3-letter word. They could say one. They could spell out the word one. Kylie?
All.
2 Skittles in all bags. Is that saying the same thing? No, that's saying in all the bags.
Many.
Many? Are we talking about many or are we talking about one? Starts with a P. 2 Skittles blank bag. Starts with a P. Brennan? Per. So in these scenarios, they give me information about one something, depending on what the label is. This one gives me for one bag. I could replace the word each with any of those words. 2 Skittles per bag, 2 Skittles in every bag, 2 Skittles in each bag. So it gives me information about one something. What is the question?
So
Kylie? So it gives me one and asks for many of those. Asks for many. And again, I'm going to write something because I'm trying to get it to work for lots of different word problems. Underline somethings, but in this case, we are talking about bags. Okay, so it gives me one, it asks for many. That is the most common 5th grade multiplication scenario that you will see. Flip your paper over to the other side. Who can read word problem number 1? Go ahead, Audrey, while I get it pulled up here.
Vanessa sells 65 crab cakes every day. How much crab cakes will she sell in 20 days?
Okay, Vanessa sells 65 crab cakes every day. How many crab cakes will she sell in 20 days? On your work page, right here where it says keywords, what tells me that this is a multiplication problem? Arabella? So it's not just the word every. But if that was in the question, it would be a division problem. Colby?
How many?
How many could be anything?
Many.
Nope. Mila?
Well,
Nope. Kylie?
N.
So here's the trick. It's not a key word that's telling us that. It's the way the words are put together. It's a certain scenario. Waylon, what scenario is it?
Every day.
So that's words. Emma? It's a give one, ask many. It's a give one, ask many. So tonight we won't actually be writing keywords. We're telling why we know it's multiplication. It's multiplication because it's a give one, ask many problem. What does it give us one? Because our scenario was it gives one something. What is our something in this problem? What does it give us one of? Waylon? Does it give us 1 crab cakes or does it give us 65 crab cakes in one day? Yeah, so it gives us the amount of crab cakes in one day and asks for many days. More specifically, how many days?
20.
Is it 20? Okay, so our number sentence would be what times what? 65 times 20. Did it say estimate? Did it say about? No, which means what math do I need to do here, Callie? Yeah, I have to do 65 times 20. We have some room down here. Do I actually have to do 65 times 20?
No.
I can do 65 times 2 and add a 0. I like to still put the 0 there so I don't forget about it. I just kind of push it out to the side so I can drop it down in my answer. 5 times 2 is 10. 2 times 6 is 12 plus 1 is 13. I'm going to drop that 0 down. What else? What else should I have? Caleb? A label's okay, but really I need more than that. Mila? A lovely sentence. I know you guys love to write answer sentences. So let's make it short and sweet. She will, what's she doing with the crab cakes? Eating them, selling them?
Selling them.
She will sell 1,300, and they're crab cakes, right?
Yeah.
Crab cakes
In 20 days.
in 20 days. Now, I only know we got through one example. What do you think all of these scenarios are going to be? Most of them are going to be give one, ask many. But read them. See why they are give one, ask many, because that's what I'm going to talk to you about tomorrow is why is it a give one, ask many? What does it give one of? What does it ask for? Because if we are not doing all multiplication. That's how we are going to pick it out. Listen, don't start moving yet. At the top of your word problems. How many are on this piece of paper? 12. At the top of your word problem. Write evens only for homework. On your answer page, it's just the back side. So we only got example 1 done. The back side, if you notice, they're numbered 2, 4, 6, 8, 10. Everybody see that on the back side? 2, 4, 6, 8, 10. So do you have to do all 12?
No.
No. But when you come tomorrow, the back side should be filled in just like that. You should have a number sentence, keywords or scenarios, and an answer sentence.
So we do that whole page.
You just do the back side, so you only have 6 problems for homework.
So the front side's
The front side will look just like this when you come tomorrow. Just that one box filled in. The back side will be filled in.
okay. So we do not do the side that we've written on.
Correct. You do not do the side that we've already written on. You only have the 6 problems on the back. And we're going to do more word problems tomorrow.